All right, L'Hopital's rule number 13. So job one is plug in, although it might be, I already have the picture there, might be helpful to rethink what the graph of natural log looks like, so that when x gets, excuse me, as x goes to infinity, natural log goes to infinity. And if you cube infinity, well, then you're definitely at infinity. So infinity over infinity, that's really as, I don't know that I could shorten it any more than that. But you're right, you got to say that, and the test tries to prompt you. I forget exactly the wording, but it says show your work and justify. I mean, there's some words in there that should trigger you to, oh yeah, I need to say it's indeterminate, therefore L'Hopital. So derivative of the top would be power rule, so 3 times natural log of x squared times 1 over x. Chain rule is where the 1 over x comes from. Derivative of x would just be 1. So let's do a little algebra cleanup work here. 3 natural log of x squared over x. Well, this is the same thing we just did a minute ago, except it's squared instead of cubed, but I'm still headed toward infinity over infinity. So let's take another derivative. So that would be 6 times natural log of x to the first times 1 over x all over 1. Again, be careful because this is not the quotient rule. This is derivative of top, derivative of bottom. It's not the same thing as the derivative of the whole thing, but it's what we want. Derivative top, derivative bottom. Algebra cleanup, so 6 natural log x over x. Same issue here. But we're making progress because we went from natural log cubed to squared to first. So I guess in some ways it feels like we're not there yet, but it seems like we're getting closer. So derivative of top would be 1 over x. Derivative of bottom would be 1. Now when we plug in infinity, I guess we could clean it up a little bit, make it 6 over x. So now when we take infinity way back over here and substitute it in, we had this problem yesterday, or something like it, right? If I take the $6 in my pocket and share it with everybody in the whole world, then pretty much everybody gets 0. So that one was L'Hopital's, 3 times? None of them were that hard. It's just kind of a pain to keep going. On those, usually you recognize, hey, I'm making progress. I know I'm not there yet, but we're headed in the right direction, so we get there eventually. Other questions?
On number 13, each time you take L'Hopital's, do you still want us in between to say indeterminate L'Hopital and then continue?
No.
You just want us to keep going.
No, I think you said it once, and as long as you've done something to indicate, like I did it with these,
Yeah.
I think as long as you've, I'll know what you're doing, so definitely say it once. And then if you show the arrow to infinity, I'll know that we're still applying L'Hopital now. We do all hard stuff all year, and your biggest complaint is, you want me to have to write out indeterminate and LH every time? Calculus problems. You said it, not me. Anything else from L'Hopital's worksheet?